Hey guys, welcome back to my channel. I'm Vivek, and in this tutorial we are going to show you how to apply machine learning on IoT data which we collected from nodemcu. So in the previous tutorial I showed you how to write a Google Apps script API to update data on Google spreadsheet. We also tested that using Postman tool. After that we wrote a C++ code that will be called from nodemcu. Now as you know that my last video was updated almost a year ago and I had stopped posting new content after that, and I'm really extremely sorry for that. I had some things going with my personal life which I set it on priority, and because of which I was not able to give time to this. And I also spent a lot of time learning new skills which we will be seeing in the upcoming videos. I will be trying to post at least 2 videos per month from now. Also, I'm active on my other social networking channels, so you can follow me on Facebook, you can follow me on Twitter, and obviously subscribe to my YouTube channel. I love you all and thank you for supporting me in this. I would not have made this far without you guys. So before starting on the machine learning part, let's see what we did in the previous tutorial. So we created a Google Apps script API which was being used by our nodemcu, which was connected to a temperature sensor, and it was updating the data on Google Sheets using this API. And in this tutorial we are going to use Jupyter notebook and write a Python code that will apply machine learning on the IoT data collected on Google spreadsheet. And this is how the data looks like right now. So we are going to use random forest, which is one of the machine learning algorithms, to actually apply machine learning on this data. Now before jumping on the tutorial, I would like to clarify some of the things. What exactly this course teaches: data collection from IoT endpoints on Google spreadsheet, which we had already seen in the previous tutorial. Abstract view about machine learning, which I'm going to give. Process to apply machine learning. These are the steps which are involved in applying machine learning on any data. And finally, applying machine learning data prediction on collected using random forest, which is one of the machine learning algorithms. Now what this course doesn't teach: machine learning. Now don't get confused, because as you can see in the title that we are going to apply machine learning on our IoT data. And to start off with machine learning, it would take more than one video to actually take you in depth of machine learning, the various algorithms, approaches, etc. Yeah, so in this tutorial we are going to see just a simple use case in which I'm applying machine learning. The output may not be accurate, so it's just a glimpse to show you how end-to-end works in terms of IoT. That how do we collect data from IoT, how do we filter the data, and how do we apply machine learning on that. Hold on to me, and please don't expect that this specific course is going to teach you all about machine learning. I'm just going to take you to the basics and directly jump to the practical part, where I'll be trying to explain line by line code and what exactly is happening in that specific section of the code. So let's get started. So what is machine learning? Machine learning is the scientific study of algorithms and statistical models that computer systems use in order to perform a specific task effectively without using explicit instructions, relying on patterns and inference instead, according to Wikipedia. So in a nutshell, machine learning is an application of AI, or artificial intelligence, that provides system the ability to automatically learn and improve from experience without being explicitly programmed. So you don't have to actually program your machine to do something. You just create a program that will automatically learn and improve from experience. For example, if we want machine to classify or to identify if a specific fruit is banana or orange, we would first train the machine and tell them, hey, this is banana, hey, this is orange, or hey, this is specific fruit. And after a certain amount of training, the machine itself will be able to identify from a new set of image that it is orange or banana or any other fruit, depending on what kind of data we have trained with. Now these are the types of machine learning: supervised machine learning, unsupervised machine learning, semi-supervised machine learning, and reinforcement learning. So in this tutorial we are going to use supervised machine learning. Now what exactly is supervised machine learning? As I previously discussed, initially the machine is taught so that the machine can perform that specific operation automatically. In our case, for example, if we are training our machine for fruits such as banana or orange, we have to give a labeled data set, meaning that we have to tell the machine that the picture right now which I am giving for training is of banana, which will be similar for all the fruits. So we have to give multiple data set of multiple fruits to the machine, and at other point of time the machine itself will automatically identify the given picture is which fruit. And the whole process of training the data is completely supervised. So that is why it is called supervised machine learning. And in supervised machine learning, we have regression and classification. So regression is something which we use to predict continuous values. The continuous values can be anything. In our case, let's take example of house prices. So if a house is priced in for $100,000 in 2001, then what should be the value of the house in 2019? Since that value is continuous, it is not a fixed value. So we can guess that on the basis of data which we have from 2018 till the previous years. So we can calculate that how the prices of the houses are going up and what will be the future value for that house. And in this tutorial, we are going to use regression to predict the future IoT data. I already have a last year's data, which I can use to predict this year's data. Now, it might not be accurate because there are some circumstances and certain data points. Depending on that, the value changes. The more data you have, the more accurate predictions you are going to get. Now, classification, on the other hand, is a problem where output variable is a category. For example, apples and oranges. In unsupervised machine learning, the training is again not supervised. For example, you do market segmentation based upon age group, your gender, your location, etc. You just feed in the tons and tons of data and let the machine categorize the data based upon their similarities. In semi-supervised machine learning, the data you're feeding into training is some of the data which is labeled and some of the data which is not labeled. Reinforcement learning refers to the algorithms which are reward based or output based. Give the machine an environment and you give the output. For example, if I'm playing Mario, then my output should be that I need to achieve highest score in less time and with less steps. So you just give the machine the whole environment and do not tell the machine that how to operate Mario in that game. The machine itself automatically figures out by trial and error, and if it sees that the scores are increasing, it will then exactly perform the same tasks which helps Mario to actually reach its goal. Now these are the basic steps which are involved in machine learning. So gathering data, what we did in the previous tutorial of collecting the data. So data source can be anywhere. It can be websites, it can be your spreadsheets, it can be your own collected data, but that has to be in a good amount. And then cleaning of data, you pre-process the data. So you clean the data, you remove the unwanted fields, you remove the unwanted data. So there might be some garbage values in your data you need to remove. So that exactly comes under cleaning or pre-processing. Then you apply your ML algorithm, you select the best algorithm. There are multiple ML algorithms which you use on specific data set and choose the best of them, which is giving you good results. And finally, gaining data insights from the model. So you get insights from all the data models which you created across all of your machine learning algorithms which you used on your data. Then finally, data visualization. So you can exactly see how your data looks like or how the prediction or the classification look like in the real world. So let's get started and quickly create a Jupyter notebook. So you can go on Google and search for Jupyter notebook online, and you will get this first link, jupyter.org.try. Just click on try Jupyter lab. This is the easiest way you can access Jupyter notebook. You can also install that on your local system as well. It will take some time to create a notebook, and so this is our environment which we get. So a lot of developers who code in Python and are in machine learning use Jupyter notebook because it is very simple and intuitive to use. Plus you can run the codes in chunks. So let's get started. First you need to download this spreadsheet. So you can go file, download as, and XLS. So this is the format which we want, which we'll be importing in our Jupyter lab. I have already downloaded the data and it is present on my desktop. I'll quickly drag and drop this data. Yeah, now it is uploaded. Now let's create a new file for Python 3, and I will quickly rename this to code.ipynb, which is a Jupyter file. Now let's start by importing pandas library, which can be used or which is usually used for data analysis and multifunctions, and quickly enter. Then we'll import numpy, which is used for matrices and manipulation with matrices and multidimensional arrays. And then we need date time to play with some of the time formats which we have in our data. And let's run it. So simply press shift and enter. Yeah. Now let's read our Excel sheet. Read Excel. data.xlsx. So we have read this data sheet and stored in the variable df and df.head. Let's shift enter. Looks like here we got an error for XLRD. So here we will open the terminal, new and terminal. Yeah, so well, this is unusual. XLRD. Okay, so do pip install XLRD. Yeah, perfect. So I'll quickly jump to our code and I'll try to again run this by shift enter. All right. Yeah, the error is gone. So now we are going to change the date format, because depending upon your data you might have some different timestamp, and we'll make it into a standard timestamp. So this code is applicable even to your dataset. Okay, let's check the info df.info. I want to see the is no null. So using df.info we get to know that formats of columns. Scribe. Let's check some more details. So this is the count of your number of rows. This is the mean value of rows for ID and value both. Then we have standard, then we have minimum and max temperature and other details as well. Now let's start off the index. Let's drop off the field date for manipulate, and your access should be 1 and in place equals to true. Now let's see the output. Now what is the difference between these two? So since we are going to plot the data, I have removed or replaced these fields. So your date goes here, your ID goes here, and then your time goes here, and then your value goes here. So this time is the timestamp. Now let me quickly plot the graph to actually show you how it looks like, so you will understand why I did the previous step. Equals to true, x equals to ID, y equals to our value, this value, and then kind is equals to, we want to plot a line graph. And okay, so just wanted a space here. So this is how our data looks like. So these are the number of fields or ID, and this is the value. Now we'll again reverse the process by going to time will be your on the axis 1 and in place for permanent and true, and we want mean, so df equals to df dot group by date dot aggregate value of value mean. So we are grouping the data by date and averaging value, which is of temperature. Okay, dictionary we have okay, typo. Perfect. Now let's see this. And so what we did right now is get the aggregate of the same date. For example, if it is 15th, then I got the aggregate of all the data which was captured on 15th of this specific date. So in this way you have a proper grouping of data, not on the basis of hourly or minute based, but your day wise data. Now let's reset the index. And after that, so we'll copy df into date temp. Again, we'll change the index df and in place equals to true. Then we'll drop the previous index equals to 1, in place equals to true. Okay, and we'll check the df. Yeah, so we have date and value now. Let's do df.describe to check our data. Okay, data frame origin. Again a typo. I have to be careful with this one. All right, so now you have the aggregate of your previous data values, and these are the data. So now let's try to plot this one. Okay, now it looks better. So we have index as date, and then we have value, and we can see the data coming from 01 2019 to 06 2019, which is 6 months data. Now we can apply some ML on this, but before that we need to again do some pre-processing on this data. So df.to, let's create another CSV file on which we will manipulate this data, so we don't want to interfere with the original one. temp1 .csv, let's name this thing, and so a new CSV is created by this name, and let's copy this. Series from CSV, let's copy it. temp1 dot to dot CSV, comma header. Let's plot this and check the result. Style equals to okay. And now don't worry if you're not able to understand some of the commands here, because I do not expect you to have a thorough background on Python. You just need to understand the process of what I'm doing with the data, which is usually the data pre-processing right now. Let's plot the data. Series stored from, okay, another typo, which is supposed to be CSV. Yeah, let's look great. So now we have copied that data to temp1.toCSV, and we have plotted here, and this is how it looks. And we have plotted the data, and this is how it looks like. Now let's reset the index. to then let's break it down into year, months and day. Here we are splitting the features, so you get more detailed feature. So here the feature is year, dates and months. To date, let me split the date first, and df, which is our original data set, date, convert it to year. And then df, I should write it in the same block. And df month equals, so wherever I'm trying to execute the code, just press shift enter. That will execute that specific block of the code. Equals to pd dot to date time, and let's split that into months. Again same thing, and dot dt dot month. I'm just going to copy this, and it should be day, and let's drop date out of index, since we have year, month and day as another feature instead of date. All right, now df equals to df of year, then month, day, and your finally value. All right, so I'm going to set a target, df value. Again I'm going to drop this value field out of that. Your access will be 1, and in place true. And let's create a feature list. Feature list equals to list of target, and features convert into p dot array of your df, which is your actual data. So we have warning. I suppose we need to we can turn the warning off by importing the warning. So import warnings and warning start filter warnings, because that doesn't look good in our code. Ignore, we're going to ignore those warnings, and yeah, I'm just printing shift enter, guys, so it will execute line by line. Yeah, so we have suppressed the warning for now. Now moving ahead, as I was there, that we need to again do some pre-processing before we can actually apply machine learning on that. Now going ahead, let's use the scikit-learn, which is one of the ML libraries in Python, which is popular, and a lot of people use it initially for their ML, because it comes in with built-in library for applying machine algorithms such as random forest and logistic regressions and other ML algorithms. So this is the library which we are going to import, and then train features. So train and split. Before going at just letting you know what I'm going to do. So I'm going to split the data into two parts, training and testing. So your training data is the data on which it is going to train. For example, so the last data set we have pre-processed consists of values, year, month and day, using which we are going to divide it into test and train. Or that will be 75% of your data will go into training and 25% will be used to testing the data. So we will be trying to use ML algorithm to actually see what it predicts versus what the actual value is. For example, if the temperature on 15th of specific month is 3 degrees, then our machine learning should be able to predict a data somewhere near that. So train features, then we have test features defined, then we have train labels, then we have test labels. Train, test, split, and we are going to provide it with features, target on which it has to write it, test size is to 0.25, and random state equals to 42. Now let's print the features. Shape of training feature will be train features dot shape. I'll simply copy this. We need to see the labels. Testing features shape. And finally testing labels. Okay. So we have finally printed the shape of our training testing labels along with features. Now let's apply random forest on our data. And simple. Let me just quickly okay. Sometimes you just don't remember the name. Cursor. So we'll start off by 1000 decision tree. I'm not going to explain in detail or even get in the basics of what random forest is. You just need to know that it is one of the machine learning algorithms. I would recommend, if you want to go depth into machine learning, I would recommend you to start from scratch and learn the basic concepts, learn how regression works, how classification learns. Again, just telling you that the task or the main context of this tutorial is just to take you through the process of how do you code to apply machine learning on your IoT data set. You can use this code in your assignments, but make sure that you know what your code does. And okay, again a typo. Fit train features train tables. So as you know that in previously we had divided our data or splitted our data into two parts, test and train, and we are going to feed in this data to your random forest algorithm. Oops, you're not supposed to use semicolon here. Yeah, so this is our result. Let's try to do prediction on our test data. Let's check the error rate. Predictions. Okay. I'm making a lot of typos here. Then print. Let's check the error rate and round off np dot mean error. So we have absolute error of 2.14 degrees. That means that if I'm trying to predict temperature of 15th March, let's say, and the temperature was 15, so result is giving us near +2 or -2 degrees error. Let's calculate the mean absolute percentage error. To do that, let's declare a variable called map 100 into errors slash test labels. Accuracy equals to 100 minus np dot mean of map. Accuracy yes. I think it should be okay. Got it. So it should be comma, and we will give okay. Yes, so our accuracy is around 88%. The accuracy is something on which we are trying to predict the data from our test data. So we try to predict the data from a given point in our test data. So if you are trying to predict the data from last year, for which we already have the test data, and the accuracy it got was 88.14%, which is not that bad. Now let's try to predict the data for a value which is known to us. So 2019 of 1st of 30th, and rf dot predict for a dot reshape, is other format, and 1,3. Now let's try to predict the data on the data. So to predict that, let's print date temp. Yeah, so this is the original data, and let's see what is the value when it is 2019, 1 and 30. Or before that, let's try to predict for the new value. So new value is date. You can take a new value as 2019 06 04. So this is the value which we are trying to predict here, and then user date equals to date time dot strip time predict date %y %m and %d for date, and dot date date temp of date temp date equals to user date. So the predicted value before was 17, and this is our actual value. So 190604. Let's try to change the date. So I hope that you like this tutorial. You can find the link for this code in the comment section below. Also, I would request you to please subscribe to my channel and also hit the notification button so that next time I'm uploading the video, so you get direct notification from me. Also, don't forget to follow me on my Facebook page and Instagram page, which again you can see in the description section below. Please leave comments if you have any questions. Thank you for watching this video. Happy learning. Hit like and share this video if you found this tutorial useful. Comment below if you have any questions, and please subscribe to my channel if you want to keep seeing awesome tutorials. And don't forget to visit iotmonk.com for more tutorials.